Welcome to class number 2. In this class we will discuss about the physical links which we use to connect computers together and the component of computer which is called network interface card, which will be the device responsible for sending and receiving data from a computer. So first let's look at different types of physical media. So basically there are two types of physical media. One is copper, another one is fiber. So as discussed in the previous class, computer stores the information in the form of zeros and ones. In order to send data from one computer to another computer, those zeros and ones need to be signaled through physical media, either using a copper cable or fiber optic cable. So in copper cable, computer will transmit the data in the form of electric pulses. Electric pulses. But in the fiber cable, computer will transmit the data in the form of light. So which one we need to choose? So basically the copper cables can only support to transmit data for lesser distances. For suppose if you have two computers in a room, you can connect using them copper cables. But if you want to connect two computers or to any devices using this type of copper cable, like around like 1 kilometer or like higher distances, it won't work because the electric signals will be like loose after traveling such distance. So copper cables are good for only for short distances, like within a room, within a rack or something like that. But you can use fiber optic cables. There are multiple types of fiber optic cables. Some of them can be used for the shorter distances, some can be used for the longer distances. So using the fiber optic cable, we can connect two devices which are like 10 to 15 kilometers away as well. So these are the main two types. Which one is better? So fiber optics have higher performance compared to the copper ones because light fast travels than the electric impulses. And so how do we connect this cable to the computers or network devices? So usually computers will have a connection and or you can call it an outlet or port for the copper cables only. So this is how it will look. Fiber optic cables mainly use it to connect different servers or network equipment only. Not for it. This is not commonly used for the computers. So this is an image of a network device. So a network device is used to connect multiple computers. So that's why it has multiple ports. So these are copper ports. How we can tell that these are copper ports? By this design. But in order to connect fiber cable, the ports will be little bit different. So the ports will be not exactly like the copper ones, they will be little bit different. You cannot directly connect a fiber cable to these ports. There is a device called SFP, small form factor pluggable device. So you will connect the one end of the fiber cable to the SFP and you will insert this into this port. This is how you can make physical connections on a network device or a computer. So let's take an example of telephone. So in telephone, how do you send voice? How do you receive voice? So basically when you try to send, there will be like a microphone which will receive your voice and will send it on the link. When the other person talks on the phone, it will come back on a speaker and you will receive the sound through that speaker. So there are two devices, one for outgoing, one for incoming. But for computer, if you take a laptop or a computer, there will be only one device, which is called network interface card. This is the device responsible for both sending data outside and receiving data. So sending and receiving both will be processed by the network interface card. If you want to connect a computer, a server or anything, it has a network interface card, and the cable should be connected to it, and other end of the cable should be connected to the other computer or a network device, so that whatever the information this computer has, if it wants to send it to another computer, the application on the computer will send the data to the network interface card, and it will send it out on the cable in the form of electric pulses in the case of copper cable, and the form of light in case of fiber optic cable. So this is how it will look inside of a network interface card. So each network interface card will have two addresses. So one is MAC address. MAC address is like serial number. Whoever manufactures this network interface card, they will already configure the MAC address on the network interface card itself. Normally, you don't need to change anything on this. It will come default like a serial number. So the format of the MAC address is, it will consist with 48 bits and in a hexadecimal format. In the class 1 we discussed that hexadecimal is 0, decimal means 0 to 9, hexa is English alphabets from A to F. So if you see any MAC address, you should be able to identify it. So it should contain 0 to 9s and A's and F's, A to F. So total this is 48 bits. So the first 24 bits are unique for the manufacturer. For suppose there is a company called XYZ is manufacturing MAC addresses, all the manufacturing the network interface card, all the network interface card MAC addresses will start with this unique number, with this unique hexadecimal format for the first 24 bits. The others will be assigned to the each will be unique to the each network interface card. So if you have a MAC address, and if you just go online and Google MAC vendor lookup, and if you enter the MAC address, the online tool will tell you who manufactured this. So this is also one of the method you can identify which type of device has this network interface card. And next value we can assign to network interface card is IP address. This is not this is configurable. So when manufacturer creates a network card, it will only have the MAC address. IP address is something like a logical address. So you can write it, you can delete or edit, you can do whatever you want, but it is a logical address. It has to be configured by network administrator. So we will look into in the next slides why we need IP address and MAC address. So most of the networking concept will be similar to the postal system. So every time you learn any concept, you should imagine similar to the letters how you used to exchange information. So when a computer wants to send some data, let's say computer A wants to send some data to computer B. So computer will have network interface card. Computer B also will have a network interface card. So if computer A wants to say hello to computer B, so first it will take a letter and write hello, okay, and on top of that it will put it in an envelope, similar to how we write letters and send it to the post office. So in this case, normally on the letters you will write from address and to address. From address is basically who is sending the letter. To address is basically who should be receiving the letter, right? So similarly, computer also uses the same things, but instead of the street address and something like that, computer has to put its own address. So it will include its MAC address, it will include its IP address in the from field. In the to field, it will include the MAC address of the computer where it wants to send the data, and it will include the IP address of the computer where it needs to send data. So these are the two fields mandatory for a packet to go from one part of the network to the another part of the network. So this will change in different scenarios. We will look into that. These values MAC address will be changing when the packet going from one location to another location. We will look into it that later, but for now all you need to remember is when computer sends a packet to another computer, it will include its own MAC address and MAC address. Also it will have the two MAC address and two IP address. So let's look into the IP address format. So IP address total 32 bits, means 32 blocks. We have equally divided them into 4 parts, 8 into 4, 32 bits. So each part we can call it as an octet because it has 8 bits. So these bits values will be double from the right to left, right? So it will go from 1 and all the way to 128. This is how an IP address looks like. Let's look at the IP address range. So if we take all zeros, then the least value of IP address will be, the lowest value will be 0.0.0.0. You know how to convert decimal binary to decimal, right? So if you convert this 8 blocks of binary to decimal, it will be 0. If you have ones in all 8 bits of each octet, you should add all the values, right? So the values will be 1, 2, 4, 8, 16, 32, 64, 128. If you add all of them, the total will be 255. So the highest possible address, IP address value will be 255. So the IP address range starts from, the lowest will be 0.0.0 and highest will be 255, 255, 255.255. So how it will go from one address to the next address? Let's look at the IPv4 address sequence. Let's take an example of time. For suppose current time is 11 hours 59 minutes 59 seconds. After 1 second, what will be the time? It's 12:00:00. So for 1 minute we have 60 seconds. So in the next second, what will happen is these 60 seconds will fill up, and so that we will increase the minute value here, right? Similarly, for 1 hour you only have 60 minutes. So after 1 second, what happened is these 59 seconds will increase the value of 59 minutes to 00, and we will increase the hour here. So just after 1 second, what happened to this value is it become 12:00:00. So this is how we calculate the time. This is for the time, right? So similarly for the IP address, it is also same thing, but in this case it has 4 values. Here you have 3, right? Here we have 4 values. For suppose, let me write first, second, third and fourth. So each one can range from 0 to 255, as we discussed in the previous slide. Same thing for these as well, 0 to 255, 0 to 255, 0 to 255. So you should start filling on the right side. If this value goes from 0 to 255, and if you want to add one more, the next value you should add it here. Similarly, if everything is filled up here, you will add it here. So similarly, it will also applicable until the first octet. So if we look at the sequence, the first address is, the lowest address is 000. Then it will become 0.0.1. It will go like 2, 3, 4, 5, 6, 7, 8 until 255. Then the next address is, if you add 1, as this is already full, it will become 0, and you need to increase the left octet. So it will become 0010. Like this, it will go like 1111. So it will go until 255. Now if we add one more, what will happen? This will become 0, and you need to increase here so that it will become 0020. It will go like that. So let's assume what will be the number after this. So if we want to see what is the next IP address, if you add 1, this is already filled, so it will become 0, and you can add here. Because it's already full, it will become 0, and you should add it here. So after 0.0.255.255, the next address is 0.1.0.0. Like this, it will go all the way to 255.255.255.255. Let's see what is the next address of this. So we should start adding from the left, right? So the next address will be 0.1.0.1, because you need to fill from the left to right, sorry, right to left. Okay. So assignment for this class is, if you have a phone and you connect it to a Wi-Fi, you can go to Wi-Fi settings and you can able to see MAC address and IP address of the network interface card on your phone. And if you have laptop, you can go to command prompt using Windows button +R and then type CMD. It will take you to the command line of your system. If you have Mac or something, you can go to type terminal in the search, so it will open the command prompt window. Once you are on the command line, you can enter ipconfig on Windows, ifconfig on Mac or Linux. Then it will print all the network interface card the system has, and it will show the values of each network card, which includes MAC and IP address. So these are the two commands that you need to remember to verify a system's IP address and MAC address. That's all for today, and yeah, you need to able to recognize the next available address. For suppose if I give some address, let's say 1.255.255.255. You should be able to tell what is the next address. In this case it will be 2.0.0.0. Yeah, so IPv4 address sequence and these two checks are for today's class assignment. We'll discuss the next topics in next class. Thank you. Bye.